Here's another two kinds of distance equals rate times time problems: catching up and there and back. In this video, we're going to analyze those problems to set up equations. We'll solve the equations and write the solutions in terms of the original problem. We're also going to summarize these problems as equal distance problems and give you a template that you can use to solve them. Here's a catching up problem. A slow freight train leaves a station traveling west at 20 miles per hour. 2 hours later, a passenger train leaves the same station traveling west at 40 miles an hour. How long will it take for the passenger train to catch up to the freight train? First, let's watch what happens as the trains go through the various hours. At the beginning, they're each at the 0 point. But after 1 hour, the freight train's traveled ahead 20 miles, and the passenger train is just sitting in the station. After 2 hours, the freight train's gone another 20 miles. It's 40 miles from the station. Still, the passenger train hasn't left yet because it doesn't leave until 2 hours later. It's about to leave. After 3 hours have gone by, the passenger train has finally left, and it's gone 40 miles because it's going 40 miles an hour. The freight train has gone ahead another 20 miles. It's now 60 miles from the station. And finally, after 4 hours, the freight train has traveled 80 miles. The passenger train has only been traveling for 2 hours, but it's also traveled 80 miles. The passenger train is about to pass the freight train. This is the moment we're looking for. How long will it take the passenger train to catch up to the freight train? In the next hour, it will pass. And 5 hours after the freight train left the station, the passenger train is well ahead. The key thing to notice here at the moment that the passenger train has caught up is that the two trains have traveled the same distance. That's how we're going to solve catching up problems. The two distances traveled will be the same. The times and the rates will be different. Well, if the two distances are the same, remember that we find distance by rate times time. Just as in the all word problems, once we have the structure, we can just fill in the numbers we know. So we know that the freight train is traveling at 20 miles an hour. That's its rate. And we know that the passenger train is traveling at 40 miles an hour. That's its rate. Now the times that they're traveling are not equal. We have the time that the freight train travels, but then the time that the passenger train travels is less than that. It's always 2 hours less time because it left 2 hours later. So instead of t for the time of the passenger train, I'm going to write t minus 2. Because t is going to stand for how long the freight train was traveling. Well, now we can simplify. 20t is going to equal to 40t minus 80. 2 times 40 is 80. Well, let's rearrange so that we can solve. If I subtract 40t from each side, I'll get a lot of negatives, but they'll all cancel out in the end. So I subtract the 40t and I get negative 20t equals negative 80. Okay, divide by negative 20, 4 hours. That's 4 hours after the freight train left the station. The passenger train has only been traveling for 2 hours at that time, but it takes 4 hours for it to catch up. A there and back problem is also an equal distance problem. here's an example. It took Jane 6 hours to drive from her home to Portland, but it took her 7 hours to drive back. If her speed on the way home was 10 miles an hour less than her speed on the way there, how far does Jane live from Portland? Well, we want to know a distance, and we know that the drive there and the drive home are equal. So let's write out a structure for the problem. The distance on the drive there is the same as the distance on the drive back, and each distance is equal to a rate times a time. Let's fill in what we know. We know times. It took 6 hours to drive there. So let's fill in 6. And it took 7 hours to drive back. So let's fill in 7. And we know a relationship between the two rates. The drive back, lower speed by 10 miles an hour. So if r is the speed on the drive there, then r minus 10 is the speed on the drive back. Well, let's write it out and solve it. R times 6 is written 6r, and that's equal to 7 times r minus 10. Distributing the 7, we have 7r minus 70 equals 6r. I'll subtract 6r from each side, and that will give me 0 equals r minus 70. If I add 70, I found that r equals 70. Well, what did r stand for? It's the rate on the way there. Well, 70 times 6 is 420 miles, so the drive there was 420 miles in distance. Now, the drive back had a slower rate. It was 70 minus 10, so the drive back had a rate of 60. And 60 times 7 is also 420 miles. How far does Jane live from Portland? She lives 420 miles away. Both catching up and there and back problems are equal distance problems. There's two travelers and they've gone equal distances at different rates and times. So this is the structure you can use to solve any of those problems.